So section 3 of chapter 15 is all about our four-sided friends, and there's a lot of them. We're going to be bouncing all around. I'm going to be here. I'm going to be in pictures. I'm going to be moving all around. You can always slow the video down. You can go back and rewatch any bits that you think you need to. So there are a bunch of different special quadrilaterals, meaning they get their own unique name. The first guy here in the top of this chart is called a parallelogram. P-A-R-A-L-L-E-L-O-G-R-A-M. Okay. What's special about this guy? Opposite sides are congruent and parallel. And yes, I'm going to use shorthand notation. So remember, the equal sign with the squiggly above it means congruent. Congruent is our geometry word for equals, which is the same. And the double L stands for parallel. So here in a parallelogram, opposite sides are equal to each other, the same length, and they're parallel. If we extended them, they would never, ever touch. Okay. Next guy we recognize as being a rectangle. Okay. A rectangle is special because he has four 90-degree angles. Four 90-degree angles. Okay. Yes, a square has that too. We'll get into that in a minute. Okay. Our next friend here, we can see all of his sides are marked as being the same. This is a rhombus. Okay. And he has four congruent sides. Okay, not just two sets of congruent sides, but all four now are the same. We all know this guy. He's a square. And he gets both of the previous properties. He has four 90-degree angles and four congruent sides. I apologize for drawing through the 90, but Microsoft Word on the iPad thinks whatever I write has to go in the middle of the block. So a square has four 90-degree angles and four congruent sides. Our next guy is a bit of a split. He doesn't really fit into the previous four, and you'll see that in a minute. He's called the trapezoid, and the zoid has one set of parallel sides. And I'm out of space. One set of parallel sides. Not two, specifically only one. And our last guy here is just the quadrilateral, and he has four sides. Okay. The quadrilateral family tree. I could try to draw it here. I know that won't go well. So, here it is. Okay, this is straight out of your book. Unfortunately, I can't really draw on this, so bear with me. So at the top of the family tree, we have quadrilateral. Every four-sided shape, quadrilateral. And then we branch off. Okay. There's two possibilities if you're not a quadrilateral. And those possibilities are that you have one set of parallel sides or two sets of parallel sides. One set is trapezoid, and he's all by himself on the right branch. Two sets is parallelogram, and you can see parallelogram is not alone. A rectangle and a rhombus are both offshoots of the parallelogram. They have the same properties of a parallelogram. Their opposite sides are the same, and their opposite sides are parallel, but a rectangle also goes, hey, all my angles are 90 degrees. While the rhombus is like, hey, all my sides aren't just opposite and parallel, but all four are actually the same length. And then you can see at the bottom of our chart, our square, who goes, hey, I'm Alia. I have your four right angles. I have your four congruent sides. I have my opposite sides are parallel. Okay. The way this chart works is as we go down, we could say some in between two words. For instance, some quadrilaterals are parallelograms because I'm going down. Is every four-sided shape a parallelogram? No. Are some of them? Yes. Some quadrilaterals are trapezoids. Some parallelograms are rectangles. Some parallelograms are rhombi, which is the plural of rhombus. Some rectangles are squares. Some rhombi are squares. On the other hand, if I go up the chart, it's all. All squares are rectangles. All squares are rhombi. All squares are parallelograms. All squares are quadrilaterals. All squares are not trapezoids because square is not connected to trapezoid going up. You'd have to turn it quadrilateral and come back down. All rectangles are parallelograms. All rectangles are quadrilaterals. All rhombi are parallelograms. And all rhombi are quadrilaterals. All parallelograms are quadrilaterals. And all trapezoids are quadrilaterals. So now, let me turn my iPad so I can see what... you little. Okay, so you can look at this. I'm going to look at it in the book. This is the bottom of page 446. And they're asking us to give the most exact name for a shape. Okay. So in A, all four sides are the same, which is a rhombus. All four angles are 90 degrees, which is a rectangle. But both happening at the same time means the best name for that guy is a square. In B, I have opposite sides are congruent, and they look like they're parallel. We can trust that here. This is a parallelogram. And for C, I know that all four sides are congruent. And which of my quadrilaterals has that property, all four sides congruent? The rhombus. In addition to classifying quadrilaterals, we are going to ask you to find missing angles. So what you need to know is that the sum of the angles in a quadrilateral is 360 degrees. So in triangles, where their sum was 180, I took 180 and just subtracted all the numbers that were inside. Here, I'm going to take 360 and subtract all the numbers inside. So inside this trapezoid in example 2, I've got a 90 degree angle, a 90 degree angle, and a 120 degree angle. If I start with 360, subtract one of the 90s, I'm down to 270. Subtract the other 90, I'm down to 180. And subtract 120, and I have 60 left over. We do not classify these by angle measurements or side lengths like we did with triangles. Okay, classification for quadrilaterals comes from using the names in the family tree.